Okay, now we're going to follow the rules for doing operations with scientific notations. Uh, if we add two numbers that are in scientific notation, the first thing we need to do is the only way to add numbers with scientific notation is to move uh, the decimal place so that uh, the power of 10 is the same. So I can't add these two numbers without these two numbers, 5 and 3, being the same. So how do I make that number the same? Well, I just move the decimal place. If I move this to the decimal place 1, 2 spots over, that means it's 367 times 10 to the third. Now, that's not in correct scientific notation form, but we need to do that in order to add the numbers together. Plus 5.9 times 10 to the third. Now I can add these two numbers together because they have the same power of 10. So 367 plus 5.9 equals 372.9 times 10 to the third. But going back to correctly adding with significant digits, we are precise to the this place in our first number. Therefore, we can only be precise to that place value. So our real number is 373 because the 9 rounds that up times 10 to the third. And if we want to put that back into correct scientific notation, move those two numbers to the left 2 times, 3.73 times 10 to the 4, 5. That's the correct answer. Uh, just to go back, you could have just moved this to the left 2 times and increase that to 10 to the fifth. And that way would have worked also, and you'd still get the correct answer. Subtraction works similar to the addition, where you want your powers of 10 to match up. So this is 10 to the fifth, this is 10 to the third. So let's make this into 10 to the fifth power. In order to do that, we'd have to move the decimal 2 times to the left. That would give us 0.059 times 10 to the fifth. And we're subtracting that, and this just comes down. So we got 3.67 minus 0.059 equals 3.611. 10 to the fifth just comes down. And we were precise to this place value. Therefore, we need to maintain that when we add or subtract. So this is really 3.61 times 10 to the fifth. Again, addition and subtraction, we need to make sure our powers are the same number, or to the 10 is to the same power, and that just comes down. We add or subtract our front numbers. For multiplication, we don't worry too much about, we don't worry about whether the powers are the same numbers. When we multiply powers, they add together. If you think back to algebra, when you had x squared times x to the third, that's equal to x to the fifth, right? So same deal works with powers of 10. 10 to the 5th times a 10 to the 3rd will give you a 10 to the 8th. And then we multiply our front numbers. 3.67 times 5.9. That's 21.653, but we only have two significant digits in this number, and when you multiply, it's a matter of the least amount of significant digits. So this is really 22 times 10 to the 8th, and that is not in correct scientific notation because we need to put a whole number behind the decimal that's less than 10. So we've got to move the decimal place over 1. That's 2.2 times 10 to the 9th. That's a 2. Again, when you're multiplying exponents, they get added together. And you just, so 10 to the 5th times 10 to the 3rd is 10 to the 8th. Multiply your front numbers together, maintain significant digits, and put it into correct scientific notation. For division, when you multiply numbers and you're dividing, those numbers subtract. So x to the 3rd divided by x to the 2nd is just x to the 1st power, or x. And why that is you may or may not have learned this in algebra, but x to the 3rd divided by x squared, x squared is on the bottom. If I do the reciprocal of that, I've got x to the 3rd times an x to the negative 2. When the 2 comes up, it becomes negative, and now our multiplication rule, multiply those two together, you just get x. So it works the same. So if you haven't learned this method, don't worry about it. All you need to know is when I'm dividing exponents, they subtract. When you're dividing with scientific notation, you subtract the exponents. So 5 minus 3 would give us 10 to the power of 2. And then we take our front numbers and divide them. 3.67 divided by 5.9. 3.67 divided by 5.9 is 0.622. That's a 6. 0.622 times 10 to the 2nd. Again, two significant digits. I need two significant digits here, so I have 0.62 times 10 to the 2nd power. And I'd actually have to move that to the decimal. If I wanted to put that in correct scientific notation, I could move the decimal place 1 and have 6.2 times 10. But we don't put numbers that are less than 1,000 into scientific notation, so in reality what I have is 62 for an answer, because that doesn't need to be in this scientific notation form.